In example 2, we'll be solving a linear equation by first clearing out these fractions. To do so, we need to figure out what is the least common multiple amongst all the denominators. What is the least common denominator in these fractions? Well, if we have a 3, that's going to clear out the 3. If we have a factor of 5, that's going to clear out the 5. If we have a factor of 10, or also known as 5 times 2, notice that we don't need to multiply by 10 here because 5 times 2 will take care of canceling out that 10. 3 times 5 times 2 is 30, and so that's our least common denominator. Now, we learned just previously that we can multiply both sides of an equation by any quantity we choose. And what we're going to decide to use is this least common denominator of 30. This just so happens to be problem number 30. Hey, that's just kind of interesting, okay? So next we're going to clear these grouping symbols, and essentially notice, okay, we're going to multiply both sides by 30. When we clear these grouping symbols, what we're actually doing is multiplying each of these 4 terms in this equation by 30. And so if we go to do that, this is going to look like 30 times the quantity t minus 2 all over 3, and then bring down the minus sign, and we're going to have 30 times the quantity t plus 7 all over 5. That's going to be equal to 30 times the quantity t minus 4 all over 10. And then don't forget, we also have to do 30 times that term of 2. Now here comes the fun part where we get to start wiping out the common factors. 3 will go into 3 one time, 3 will go into 30 10 times. Okay, so our fractions are now reduced. That leaves us with 10 times the quantity t minus 2, which when you distribute that, we're going to have 10t minus 20. True. Moving on to the next. 5 will go into 5 one time. 5 will go into 30 6 times. Here we're going to need to remember to run the negative 6 through to both of these terms. So negative 6 times t is a negative 6t. Negative 6 times positive 7 is negative 42. Watch out when this is a negative. People like to mess that up. Okay, reducing the 10 here. 10 will go into 10 once. 10 will go into 30 3 times. 3 times. Now we will distribute. 3 times the t leaves us with 3t. 3 times a negative 4 is negative 12. Then, nothing to reduce for this last one, so 30 times 2 is 60. Combining some like terms on each side of the equation, the 10t minus 6t combines to give us 4t. Negative 20 and a negative 42 combine to give us negative 62. On the right-hand side, bring down the 3t, and negative 12 and a positive 60 combine to give us positive 48. Now, gathering up constants on one side, maybe over here, variables on the other side. This time I can subtract 3t from both sides. And if I'm going to move my variable terms to the left-hand side, I'm going to move constant terms to the right-hand side by adding 62 to both sides. Okay, 4t minus 3t leave us with 1t, or just t is equal to 48 plus 62, I believe, is 110. There's our solution set, 110. You can check that if you would like. On the next example, this is an application problem. This says a single subway ride is $2.25 per ride. On part A, it says write a model for the cost in dollars for X rides on the subway. So the total cost is going to be equal to cost per ride, which that's the $2.25 times the number of rides. Cost per ride times the number of rides. So then on part B, this says that a commuter can purchase an unlimited ride Metro card, and it's going to cost that commuter $89 per month. How many rides are required for a commuter to save money by buying the Metro card? So we're going to see where $89 is going to be equal to 2.25x. Where the cost of the Metro card is going to balance out to being equal to the cost per ride times number of rides, if you do it that way. Now, what we'll do next is divide both sides by 2.25 to solve for x. And when we take our calculator and divide 89 by 2.25, we get that number is 39.5, basically repeating, okay? And that's going to be rides. That's equal to, on the right-hand side, x. Now, I don't know how you take approximately 39.5 rides. At 39 rides, paying cost per ride of $2.25 is going to be a better deal. But if you take anything over 39.5 or 40 rides on the subway, that is where you're going to start saving money.